Hello everyone. So in this video, I'm going to cover the CI/CD process in DevOps, which is the most critical component of a DevOps workflow. So let's talk about the CI part first. CI stands for continuous integration. So this is a software development practice where the team members of a software project are going to frequently integrate or merge their code changes into a central shared repository. So here we are talking about a software team that uses a version control system. So the most popular version control system is Git, and usually that is used in conjunction with a cloud hosting service like GitHub or Bitbucket. Okay, so you have a software team that's going to be using GitHub, Bitbucket, GitLab, any kind of cloud-based version control system, and they are going to have a shared repository that's hosted on that cloud platform, whether it's GitHub or Bitbucket, and this shared repository is basically going to hold the main code base for their project. Okay, so what happens is as the team members work on the various aspects of the project, okay, they are going to merge their changes, their development back into this central shared repository, and they are going to do this frequently. Okay, so the keyword here is it's going to be done frequently. Therefore, the idea of continuous integration. Okay, so once they merge their code changes back into the central shared repository, there will be a build of the main code base. Build means compilation. Okay, build is the technical term for compilation. So when you compile your source code to get your executable code, that's called a build. Okay, so you're going to build the main code base, and after that you're going to run some tests, okay, to check that there are no errors in the latest code changes. So typically you are going to run unit tests, although you can also run more advanced tests. We'll talk about testing later. Okay, now for DevOps workflow, the merging process, the integration process, the building process, and the testing process are going to be automated, which means it's all going to just run automatically in the background without the developers needing to manually get involved. Okay, so automation is a key feature of any kind of DevOps workflow. It's also a key feature of your CI/CD pipeline. Okay, and we are going to use a CI server for this purpose to automate this. And one of the most popular CI servers is of course Jenkins, but there are also obviously other options as well. Okay, so for those of you who are unfamiliar with Git, I'll just give a short explanation of what I'm talking about. I also have a separate video to talk more about Git if you are completely new to Git. So basically, you have a shared central repository that's hosted in a cloud hosting service like GitHub or Bitbucket, and this holds the main code base for the software project. And then what will happen is all the team members of the software project that's working on the code base, they will clone or they will pull down a local copy of the main code base to their development machines, and then they will work on this local repository. They'll make commits. Commits is basically changes to the code base that you want to put into the VCS. Okay, and then when they're done, they're going to push all these changes back to the repository. Okay, so the idea here is you want to be constantly pushing after you make a certain number of changes. That's the whole idea of CI, is you are going to frequently integrate or merge your changes, whatever changes you make while you're working on your local repository, back to the remote repository. Okay, so typically the way that developers work on a shared code base is through what is called a feature branch. Okay, so here the green circles represent the commits on the master branch, and the master branch really represents the code base that is in the central shared repository. Okay, so when you as a team member of a software project, when you download or when you clone a repository to your local machine and you make commits, you are basically going to work on a separate branch that starts from the master branch. Okay, so this is basically the blue circles represent, for example, the commits that are made by you that start from the master branch. Okay, and this is basically represents changes that you make to the original code base in order to implement some new feature. So this is possibly all the commits related to your work, and this is possibly commits related to somebody else's work. Okay, so you're going to have a bunch of people working together in tandem on a software project, all of them are working at the same time on different feature branches to implement different features in the application. Once your code changes for your feature that is assigned to you is complete, you can then merge, okay, your latest changes back into the master branch. Okay, so that is the point where you're going to push all the changes you made back into the master branch on the shared central repository that is on GitHub or Bitbucket. Okay, so that's essentially what you want to do. So here we have a very simple workflow. You only have maybe just 2 feature branches. Okay, now in a real life situation, you can have a more complex workflow where you have multiple branches. So you're still always going to have a master branch which holds the main code base for the project. And then below the master branch, you can have many more branches. You can have like a hotfix branch, release branch, development branch, and then multiple feature branches. And these branches can be even subdivided into sub branches, and then these sub branches can then further be merged into the secondary branches, and then these secondary branches can then be merged back into the master branch. So the branching workflow can get really complicated if you want. So you can keep it very simple like this if you want. So for small projects, you basically might just have just one or two feature branches that start off from the master branch. And for more complex projects, okay, involving many team members, you might have a more complex workflow. Okay. Now, regardless of whether you have a simple feature branch workflow like this or you have a more complex workflow, the important point is to avoid what is called integration hell. Okay, what is integration hell? Integration hell is like this. Integration hell means that, let's say you have 4 developers and they're assigned to work on 4 different features for a particular application. Okay, so what happens is after they've been assigned this to work on all these 4 features, they all go into their rooms and cubicles or whatever. They lock themselves inside there. They don't talk to each other. They don't talk to anyone else. They just sit there for 1 whole week just writing code, and they do not commit any of their changes to the repository. Okay, so you think about it, there are 4 developers here. They're all working on their own. They're writing hundreds and thousands of lines of code. They do not know what each other are doing. So, developer A doesn't know what developer B is doing. Developer B doesn't know what developer C is doing, so on. Nobody knows what each of them are doing, but they're writing a lot of code and they think, wow, that's so cool. I'm not talking to anybody else. I'm so productive. And then at the end of this, after 1 week, after 2 weeks, okay, not talking to each other, they merge their code. So then they do this, they push all their changes back to the central repository. And at that point of time, you'll discover that a lot of code that they've all written are actually conflicting with code from some other team member. So there's going to be a lot of conflicts, okay? And therefore, they're going to spend a lot of time sitting around trying to merge the conflicts, to resolve the conflicts successfully. And if you are doing this 1 day before your product is due to ship, then you are in deep shit, basically, okay? So you want to avoid this integration hell scenario, and the way you avoid this is by doing CI. Okay, so CI is a cultural mindset. Okay, it's nothing to do with tools. It's nothing to do with Git. It's nothing to do with Bitbucket. It's nothing to do with Jenkins. It's nothing to do with Docker. It's basically a cultural mindset. Your mindset must be, I am going to talk with the team members in my software project team, and we are going to frequently, the keyword here is frequently integrate. Okay, so what is frequent? Okay, that's up to you. Okay, maybe it could be once a day, it could be once in 2 days, it could be 2 times 1 day, okay? Up to the software project team, up to the complexity of the project. But the idea is you want to do it frequently, okay? If you don't do it frequently, and you just, like I said, you just like have team members don't talk to each other, sit in a cubicle apart for 2 weeks, and then finally try to merge, then you get integration hell. Okay, so with the CI/CD tools that we're going to see later on, they will actually do a build and a test every time you push to the central repository. So coming back here to this diagram, so let's say initially you pull off to your local repository, and then you make some changes, okay, and then you have some changes here, you made some commits to your local branch, and then you push this local branch to the remote repository. So the moment you push to the remote repository as part of CI, okay, the CI server will automatically build your code, will compile your code, check to see whether it can compile, and then it will also run some unit tests on your code. Okay, so all of this is done in the background, and that's the whole idea. It must be automated. Automation is a key feature of CI/CD and also a key feature of DevOps in general. So all of this should be automated. Okay, so that means the moment you push, the compilation is done for you, the testing is done for you, and then somebody will tell you, hey, your code is crap, there was a problem, please fix it, or that was fine, continue doing whatever you need to do. Okay, so all of this is constantly being done until the final stage. When you merge back, there will be some review and approval process before your branch gets merged back into the master branch and so on. Okay, so all of this is going to be done automatically for you by CI/CD tools like Jenkins. Okay, what's the benefits of CI? Well, again, the keyword is automate. You're going to see this word again and again and again. Automation means it all happens in the background. You don't have to worry about it. You don't have to click a button. There's no chance you will forget about it because it's built into the system. Okay, and if you do CI means you're doing the merging process or the integration process frequently. That means you will pick up any conflicts, any merge conflicts, any bugs. You pick it up early on. You're not going to wait until one day before you ship your code to merge, because then it's too late. There are hundreds and thousands of conflicts you need to fix. So you do it frequently, you pick it up early on, it's resolved. That means you don't waste so much time quarreling with your team members. So it means better productivity for you. You deliver the updates faster and so on. And of course, there is good communication as well between team members. And the idea is you want to standardize the process of merging, resolution of conflicts, and bug fixing by automation. So you're going to maybe have some kind of project software, maybe like Slack, that helps you to schedule, like, okay, every 2 times a day, everybody is going to merge into the master, the shared central repository, or every once in 3 days, everybody is going to merge into the master branch, or, okay, something like that. There's going to be some standard. Everybody is going to follow the standard. Everybody's going to communicate with each other. Okay, so the key aspects, again, you can see the word automate, automate, automate. Everything is automated. So the build is automated as well. So the moment you push a code change to your central repository, the VCS will trigger some kind of signal to the CI server, and the CI server will do a build, which means a compilation of your code base. Okay, then of course there's testing as well. Then testing is also done automatically, and normally you want to do the test all the time. Okay, typically what developers tend to do is they only wait until the entire application is complete, then they do the testing, which is not a very good practice. The idea is every time you make any kind of change to your code base, even if it's just a small feature branch or it's to the main branch, doesn't matter, you run a test. And you run a test for all the branches, not only the main code branch, but also all the feature branches. So that means the moment, like I said just now, the moment you push a change for your feature branch to the remote repository, you already want to run a unit test on it. Okay, so run a test for every change made for every branch. And then if the tests succeed, which means all the tests have been run on all the code changes, none of the tests fail, then the build artifacts, okay, build artifacts basically are things that come out from the compilation process, like your executable file. So if you're like compiling a C++ program, then your build artifact is executable file. If you're compiling a Java web project, then your build artifact is a WAR file. Okay, a WAR is a short form for web archive file. So you're going to have many different kind of build artifacts, and once the test succeeds, you're going to automatically deploy the build artifact to a web server. Okay, now why I mention web server is because most of the time your applications you're writing, it's going to go onto a public web server where your customers or your end users can actually use the application, okay, through the web server. So your application is going to run on a web server. This could be Internet IIS, this could be Nginx, could be Apache, Tomcat, okay, Jetty, any kind of web servers or even servlet containers that we have now. And this process usually will involve something called containerization, which is usually done using Docker, and I'll talk about Docker in a subsequent lecture. All right, so that are the key aspects of CI. And in terms of testing, right? Testing is very important because tests, as I said, testing should be automated. You're going to run a test for every change made. You're going to run a test for all the branches. So testing is very important, and there are several types of tests. At the CI level, we are primarily focusing on a unit test. So the unit test is typically written by the developer. So there are various frameworks for unit tests. So in Java, you have JUnit. In C#, I think you have CUnit. Okay, Python, you have something else. I can't recall the name of it. But you have basically different unit testing frameworks for different programming languages and platforms. So the idea of this unit test is to verify that all the methods or functions behave correctly. So you call a specific method and you check that it gives you back the correct result. That's the simplest type of test, and that's the kind of testing you do at the CI level. That subsequent levels in your CI/CD pipeline, you are going to do more advanced tests. So for example, integration test is where you test multiple components. So let's say your application has several classes and you use your classes to create a service. You want to check that your classes, the methods in your classes can call each other correctly. You can create objects from the classes and so on. So they all work well together. Okay, that's integration. Acceptance is even more advanced, which is it's going to focus on the business use case. So typically when you are developing software for a end user or for a client, you usually have a product owner, product manager, business analyst who will talk with the end users, and they'll develop a set of use cases for the software, or sometimes we call these use case stories or user stories, okay, depending on the development methodology. And so then you are going to test your code to see whether the business use cases given by the business analyst or by the product manager works or not. Then you also need to have UI tests. This is particularly important if you are writing a web app. Okay, so like you're developing a social media app, or you're developing an e-commerce app. Anything that involves people, you know, working with your app through a browser, you need to have a UI test. So usually you will have various kind of tools that will test the browser, and you have to test multiple kinds of browsers. Like you have to test Firefox, Edge, Chrome, Safari. You have to test them on multiple platforms, Mac OS, Windows, Linux, and so on. So this all has to be done, okay? But for the CI stage, as I mentioned, you just only want to focus on unit tests. All right, so that is CI. Then you have something else called CD, continuous delivery. So what is continuous delivery? Continuous delivery is an extension of CI where the latest code changes are automatically prepared for a release to production. Okay, so remember that at the end of the day, after you have made all those latest code changes, your main code base has been compiled, it has passed all the tests, your code base is going to be deployed on a production server. Production server means the actual server that your end users or your clients will access, okay, in order to use the functionality of your app. Okay, so CD is actually talking about how do I get your compiled code base that has passed all the tests, how do I get that working code base onto a production server? That's what CD is about. Okay, so what happens is, before we actually take your build artifacts, so the build artifacts, like I mentioned just now, this could be an executable file, or this could be a WAR file, okay, a web archive file, or any kind of file that you use, or any kind of, you know, program or file, whatever it is that has come out from the compilation process that you're going to put onto the production server. So these build artifacts, of course, you have to make sure they are passed all the tests in the CI stage. And then you have to put them onto what is called a staging environment. Okay, what is a staging environment? The staging environment is used to perform additional testing before you deploy your code to the production server. Okay, so just now I mentioned that at the CI level, okay, the kind of test that you do, is basically unit tests. So unit test is just very basic tests, okay? But you can't release your code to your customers before you do all these additional tests. So you need to do integration testing, acceptance testing, UI testing, and so on. So all these tests have to be done. And they have to be done on the app that's running on a server that is essentially replicating the same server environment as your production server. Okay, and that is the purpose of the staging environment. The staging environment is a simulation of your actual production server. It has the actual operating system, it's the actual server software that's used on the production server. It has the same database, it uses the same ports, it has the same firewall. It has literally the same environment as the production server, and your code is put in the staging environment first for the sole purpose of doing testing, and more specifically to do all these higher level tests. That's the whole idea of a staging environment. Okay, and then at the same time, your code base that has passed through the CI phase, you can also push it to another central repository, and this central repository is only to hold code for deployment to the actual production environment. Okay, so then now you have two central repositories. One is a central repository for your production environment, and you have another central repository which is just for CI. CI is at the stage when you're just actually building up your app. Okay, so once your app has been fully built up, it's passed all the unit tests, okay, then you're going to put it in another different repository. And the idea is that when you need to deploy anything immediately to your production server, you can do that immediately from this other central repository. Okay, so that is the whole idea of CD. CD is going to do these two things here. All right. Now, as I said, CD is going to do more extensive testing. So the testing will be like all those tests that I talked about just now, UI testing, integration testing, and so on. And the tests are performed in staging environments. Okay, so like I said, the staging environment is an environment that replicates the actual structure of your actual production server, but it is for the purpose of just checking or testing that your application code base works as it is meant to, okay, through all these testing procedures. Now, how many staging environments do you need? It's up to you, okay? So for some companies, if you're working on a very small project, you may not even need a staging environment. If your app is very, very basic and you only have about 10 or 15 people who are using your app, then probably you don't need so much complexity. If, however, you are a company like TikTok or, Amazon or Google or Uber or, Lazada.com.my, or Grab, okay, so if you're a company where your app is accessed by hundreds and thousands or even millions of users, then you need to actually do a lot of testing. Then you need to have a lot of staging environments, and then you also need to set up the IT infrastructure for your staging environments. So your IT infrastructure is your servers, your databases, your operating system, your network routers, your firewalls. All this has to be set up for the staging environment, and you can set this up also in an automated manner in the DevOps workflow using something called IAC, which I'm going to talk about later. Okay, so once you have done all this testing, UI testing, integration testing, you have tested all of this in your staging environment, then let's say it passed all the tests have passed, then in the final stage of a CD, you are going to have the DevOps team, someone in the DevOps team, the project manager, whoever, is going to sign on a form and say, okay, everything has passed, all the latest code changes is okay, they've all passed. Now we can deploy it directly to the final production environment, to the final production server. Okay, so that is the final step in CD. So you can see here that the CD stage involves what is called the staging environment. So the staging environment, as I mentioned, is an environment that's kind of similar or identical to your production environment, and the whole purpose of the staging environment is just to run all the different kinds of tests. So there may even be security tests. So other than your integration tests, your system test, function testing, performance testing, load testing, this testing, that testing, there are literally hundreds of kinds of different testing you can do. You're just going to do all that testing in the staging environment. And then when everything has passed, somebody's going to sign on a form, and then the code then gets deployed onto the actual production server, and your clients start using it. Okay, so that is continuous delivery. Okay, then you will also see there's another term that's used that's called continuous deployment. So what is this term? How is it different from the previous term? What is the difference between continuous deployment and continuous delivery? Continuous deployment is one step further from continuous delivery, where the final code base that has passed all tests goes to the production server in an automated manner, and there's no longer any need for explicit human approval. Okay, so let's compare this, right? So in continuous delivery, before you deploy to production, there is going to be some human intervention. That means there's going to be some meeting where people will sit around and say, okay, you know what, let's discuss the code. Yeah, I think the code is ready, blah blah blah. Then somebody will sign on a form, whatever, and then somebody will click on a button, and then the code will immediately go out to the production server. That is continuous delivery. Continuous deployment is one step further. There's no meeting at all. There's no meeting, there's no project manager or sign off on a form, whatever. That means basically everything is fully automated. So that means from the time you as a developer click on the build button or click on the commit button to commit your latest code changes, the moment you click on commit, everything will just flow smoothly all the way right down to the production server. Okay, so that means within like 5 to 10 minutes of you clicking commit on your IDE, your client will be able to access the latest changes on the production server, because everything will just flow smoothly all the way to production. Okay, that is continuous deployment. So continuous deployment obviously is the fastest. It allows product changes, fixes to be released faster and more frequently, and also accelerates the feedback loop from customers. So obviously, if you are getting out your latest features or your latest bug fixes to your customers very quickly, right, then your customers will be happy, right? Your customers will say, oh, I noticed there's a problem with your app. Okay, the customer sends in an email, 5 minutes later, the bug is fixed already. Holy crap, how fast is that? Okay, so most companies will take 3 or 4 days to work on a bug fix, but in this company, 5 minutes bug fix is already done. Okay, so that is done through continuous deployment. Okay, so usually you'll see this term used a lot, CI/CD pipelines. Okay, when you talk about DevOps, you talk about CI/CD. These two terms are used a lot. These are basically the core of DevOps. So CI, of course, is referring to continuous integration. Now CD can either refer to continuous delivery or continuous deployment. I've already explained the difference between these two terms. There's a slight difference. Okay, not really that much. Okay, you already understand the difference. So they are sometimes used interchangeably. We don't really care. Okay, because we kind of know what they mean. And the CI/CD pipeline, as I said, is a key part of DevOps. The idea is to get working apps to customers as quickly as possible. And again, the keyword is automation. Every single stage is automated. Okay, you click on your button on your IDE, 5 minutes later, your app is available for your customer to access, because everything is automated all the way till the production server. Okay, so integration, building, testing, delivery, deployment, everything is fully automated. That is the end goal of CI/CD. Okay, so this is your CI/CD pipeline. So from the moment you click the commit button on your, your VCS client or on your IDE, then it goes through a build process. Okay, then there's a build, then there's a notification of build outcome. So compilation is okay, then you run the test. There's a notification of test outcome, test is okay, then you deliver the build to staging, then the staging is testing, then everything is okay, you move it to production server. Everything is 100% automated. Sometimes you talk about test gates. So testing is very important. Okay, I'll keep stressing this, because the whole idea of making sure that you get good quality code to your customer is testing. If you don't test, how do you know your code works? Okay, so CI/CD is not only just about getting code very quickly to your customer, because if your code is crap, your code is lousy, your code crashes all the time, what is the point of getting lousy, crappy code to your customer very quickly, right? That just pisses people off. So you want to have a lot of testing. So typically we have this term, sometimes you see people use this term, it's called test gates. What is a test gate? Well, the test gate is that it's like a barrier that the code base has to pass before it can go to the production server. So that is what we call the test environment gate, which is basically you have to make sure your code can compile. You have to make sure that the unit test has passed or processed, and you have to make sure that the developer has clicked on some button to say, hey, I verified that I wrote this code and it wasn't someone else who wrote this code for me. Okay, then you have the pre-production gate, where all the other tests, UI tests, automated UI tests, system testing, integration testing, user acceptance testing, whatever testing. Okay, so that has to be passed, and then finally you go on to production. So this is what people mean by test gates. And the number of test gates you have, again, is up to you. So if your code is not very critical, your code is going to be used only by 10 people, and those 10 people only use your code once in a week, okay, then you don't even have to really bother about testing at all, because those 10 people can just send you an email, you can fix it. If your code is going to be used by 10 million people who are using it 24 hours a day, then you obviously want to have as many tests as possible before your code hits the production server. Alright, so what are the CI/CD tools that are available for us to automate this entire pipeline? Okay, so Jenkins is probably the most popular one. It's been around for a long time. And then there are others as well. Circle CI, Travis CI, they all are kind of similar to Jenkins. They are also a CI automation server. So they have the same kind of functionality. And then you have GitLab, GitHub, Bitbucket. All these three are actually Git cloud hosting services. So these three things are actually, they're not really CI/CD, but they are mainly actually, or they originally started off as just hosting a Git repository in the cloud. Okay, but of course, over time, they have expanded, they have additional functionality. And because now DevOps is the hot trend, it's been already a hot trend for more than 10 years now. So obviously, they want to buy into the trend. So they also integrate CI/CD functionality into their, their code hosting facilities. Okay, so you'll find this definitely with the top, I can think these are the kind of the top 3 Git cloud hosting services available commercially right now. So all these 3 are probably going to have all the standard CI/CD functionality that you have in Jenkins and so on. However, also these 3 things also will allow you to integrate Jenkins with them as well. So most of these tools also can play with each other. So it's not like if I use GitLab CI/CD or I use Bitbucket CI/CD, I cannot use Jenkins. No, that's not the case. So you always have the option of using or interworking different tools. That's always the case now because all these tools are very popular. And then of course the cloud also has their own CI/CD tools. They are built into the cloud service itself. So AWS has one and Microsoft Azure also has one as well, and that also can play with Jenkins as well. Alright, so that's a quick overview of CI/CD.